Hello students, welcome to the online class of physics, paper 1, mechanics, unit 1. I am N. Chandana, assistant professor of physics from Government Degree College, Khairatabad, Hyderabad. So today we are going to solve some problems on mechanics, unit 1, vector analysis. So that you will be having a brief idea as I promised in your when I am teaching your unit 1. Let us do some few problems on each and every concept which we have learned in during unit 1, right? Vector analysis. I hope you remember those topics. See, first problem let us do. Given, so they have given that phi a scalar function which is in x, y and z, that is to be x square minus x square y plus x y square z square. Okay students, now what did they ask? Find the value of gradient is gradient of phi or rad phi at point, what is the point they are asking about? 2, minus 1, minus 3. Okay, so I want to find out the gradient of scalar function phi at this particular point 2, minus 1 and minus 3. Now let me calculate that. So grad phi will be, what is gradient of phi? Gradient or del, what is the operator del? I dou by dou x plus j dou by dou y plus k cap dou by dou z, right? Of phi, right? So what is del phi? I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z, right? So what happens now? So I cap, now I want dou phi by dou x, dou phi by dou y and dou phi by dou z. Okay. So what is dou phi by dou x? Tell me now. 2x minus 2xy plus y squared z squared. Right from here. My function is phi is this. So 2x minus 2xy plus y squared z squared, because it is with partial differentiation with respect to x. Now with respect to y, what I'll get? Minus x square plus 2xyz square. This is with respect to y. And with respect to z, dou phi by dou z equal to 2xy square z, right? So dou phi by dou x is this, dou phi by dou y is this, and dou phi by dou z is this, right? What about at point 2, minus 1 and minus 3 I want to calculate. So let me substitute here itself, or else you can substitute here and you can calculate grad phi here, but let me substitute here. So dou phi by dou x at what point ma? 2, minus 1, minus 3. So instead of x we substitute 2, instead of y we substitute minus 1, and instead of z we substitute minus 3. Now what I'll get here, you tell me. So 2 into 2, 4, minus 2 into minus 1 plus minus 1 whole square into z square. What is z square? Minus 3 whole square, right? 4 plus 4 plus 9. What is that? So finally I'll get 9 plus 4, 13 plus 4, 17. So my dou phi by dou x is 17. Similarly, dou phi by dou y equal to minus 2 whole square plus 2 into minus 1 into 9, right? So what I'll get here is minus 4 minus 9 4 36. So minus 40. So dou phi by dou y is minus 40. What is dou phi by dou z here? 2 into minus 1 whole square into 3, minus 3. So minus 3 4 12, 12. So this is minus 12. Hence what I'll get? Grad phi is equal to 17 I cap minus 40 j cap minus 12 k cap. Okay, this is gradient of phi. Okay, so in this way we calculate the gradient of a scalar function at a particular point. Okay, similarly we have the electrical field is given by, we know that, see, we know the relation between electric field and scalar potential. E is equal to minus grad V, right? If in exam they'll ask you, find out this electric field, okay, component at a particular point p x comma y comma z, okay, uh, due to scalar potential v function v, then we can easily calculate the electric field vector also. Okay, let us do some more problems. Now regarding the position vector, let us do some problem on position vector. So we know that position vector is r bar is equal to xi cap plus yj cap plus zk cap, right? So we know that. Now what would be grad r? Grad r is equal to, what is gradient? This. Now grad r will be there only when r is a scalar function. No, but it is a position vector. So we have del dot r, that is divergence of r bar. Okay, del dot r, that is equal to dot product of divergence and r bar. What is del? I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z dot xi cap plus yj cap plus zk cap. As you remember, divergence and curl will be there only for a vector function, while gradient is only for exclusively for scalar function, because it relates a scalar field into vector field. It translates a scalar field into vector field gradient. So what happens now? I cap dot I cap is 1. So dou by dou x of x is 1. 1 plus 1 plus 1 equal to 3. So del dot r bar equal to 3. Okay, del dot r bar is equal to 3. Okay, students. So this is the way we calculate the divergence. Okay. Now let us calculate a few more problems. See, if r is the position vector, that means xi cap plus yj cap plus zk cap. Okay. Now phi is equal to log r. It is log of mod r. Now find grad phi. So how do you calculate? First we shall calculate phi. So log of, what is r? Mod r, root over x square plus y square plus z square, right? So log of mod r is equal to log of x square plus y square plus z square whole power half. So half log x square plus y square plus z square, right? Now I want to calculate gradient of phi, that is grad phi, that is I dou by dou x of this function log r plus j dou by dou y of this function again log r and so on. So what I'll get now, let me calculate first log dou by dou x of log mod r. So dou by dou x of log x square plus y square plus z square. What is log x? Differentiation 1 by x, right? So 1 by x square plus y square plus z square, but with respect to x, right? So I get it as 2x. This is dou by dou x. Similarly, dou by dou y of log mod r will be 2y by x square plus y square plus z square. Similarly, dou by dou z of log mod r equal to 2z by x square plus y square plus z square, right? So what will get by this? So del phi will be, what you'll get, or gradient of phi will be 2 common into xi cap plus yj cap plus zk cap by x square plus y square plus z square, right? So 2 into what is xi cap? R bar. This is vector, right? Mod r square, right? Because x square plus y square plus z square root will be mod r. So mod r square, like square. So what did I get? Rad phi is 2 r bar by mod r whole square. Okay. In textbooks, if it is written in thick, like in this way they'll write, then this is a vector. If it is normally written like this, that is a scalar. Okay, that means that is a modulus of r. Mod r is a scalar, that is gives you magnitude. But when we write the components I cap, j cap and k cap, then we come to vectorial representation. Vectorial representation, right? Now let us clear the board. Let us calculate a few more problems regarding divergence. Let us calculate divergence, already we calculated. Let us calculate divergence for a point, right? Of a vector at a particular point. A bar is equal to I cap y plus j cap into x square plus y square plus k cap into yz plus zx. Okay, this is the given vector field A bar. Now divergence of A, they are asking us to calculate. Div A at 1 comma minus 2 comma 3. This particular point they are asking us to calculate. So how do you calculate this? Now divergence of A, del dot A equal to, we know that I dot I is 1. So dou by dou x of y plus dou by dou y of x square plus y square plus dou by dou z of yz plus zx. Right? What is dou by dou x of y? It is 0 because y with respect to x partial differentiation is 0. Dou by dou y of this one is 2y plus dou by dou z of this one will be y plus x, right? So 3y plus x is my divergence at of vector field A. At a particular point 1 minus 2 3. So I substitute these values. 3 into minus 2 plus 1, that is minus 6 plus 1, that gives you minus 5. So minus 5 is my divergence. Divergence is here negative, but that means divergence is negative means it acts as a sink. When divergence is positive, del dot A is greater than 0, that is it is a source. When divergence is 0, we already discussed, it is an incompressible fluid. Incompressible fluid. That means there is no change in density. The density is constant. Okay, students. The density is constant. Okay. Now let us calculate a few more problems on curl. Let us go and calculate some curl. Okay. Now, see, given a bar is equal to some iy plus x square plus y square into j plus k into yz. The same function I am taking, what I have taken for divergence. You can easily understand the difference between divergence and curl now. I want to calculate curl A bar. But I cap, j cap, k cap. So dou by dou x, dou by dou y, dou by dou z. Here y, x square plus y square and yz plus zx. Right? This is nothing but del cross A. Okay. Now what do I get? I cap into dou by dou y of this one. Z. Right? Here. Dou by dou z of this one. What is that? Dou by dou z of this one? 0. Minus j cap into dou by dou x of this one? Z. Dou by dou z of this one? 0. Plus k cap into dou by dou x of this one? 2x. Minus dou by dou y of this one? 1. Okay, so finally I'll get zi cap minus zj cap plus 2x minus 1 into k cap. So at a particular point, again 2 comma 0 comma 0, let us put that simple. So as z0 0 minus 0 plus 4 minus 1 into k cap. So I'll get as 3k cap, right? 3k cap. See, it's a vector. Cross product is a vector. So my cross product is 3k cap. Where I got in the previous result, I have got it as 5. That is scalar. This divergence is always a scalar. Okay, students. Now let us go. Calculate. Okay. So you understood now till now what are those problems you have. We can even do the triple cross product and all. Okay. Even we have done some problems regarding center of mass. I suppose we have done that in the previous class. If at all r bar is given, you know the position vector, and f is given, we can calculate the tau also. Tau is equal to r cross f. Okay, we can easily calculate those things. Okay. So these are the few examples of problems which we have taken care in our mechanics unit 1. Okay, so unit 1 you have all the problems regarding, first you have to learn what is a vector. It is a scalar quantity, vector quantity, scalar quantity, scalar product, vector product, scalar triple product, vector triple product, and then we have come to a vector integral, that is vector integration, that is line integral, volume integral, and surface integrals. Okay, then we have done these theorems. What are those theorems? Stokes, Green's, and Gauss divergence theorem. So Gauss divergence theorem relates volume and surface integrals. Green also the same, volume and surface, but Stokes relates line and surface integral. So there we have done all these things, and we have even known first of all gradient, curl, and divergence. So gradient will be there for scalar field, curl and divergence will be there for vector fields, right? So we have calculated the problems related to all these topics. So we have seen Newton's laws, mechanics. So first law, second law, and third law. And then we have gone for collisions, elastic and inelastic collisions. And we have to determine the impact parameter and scattering cross section. Let us do in the next class. And we have come for special theory of relativity. Okay. There we have done some beautiful concepts there. Okay. Then let us go back. To our PPT. So finally, we have done all the problems on vector analysis. While teaching the class also, I have done some problems on vector analysis. And this is the final one. Okay. So thank you, students. Thank you so much for your patient listening. So all the best. And you have to practice all the problems when when you learn some topic related to some problem, some theory, then immediately you have to learn the problems related to that, and immediately you have to practice them along with us. So theory, the problems won't come directly from clouds on you. They'll be related through theory itself. So once you understand the concept of theory, you'll be easily able to do the problems also. Okay. Don't think that problems will come somewhere else from somewhere else. Okay. They'll be coming only from the theory itself. You should understand the question. You should relevantly solve the problem, applying the formulas which we obtain using the theories. Okay, students. So thank you so much for your patient listening. So Take care. Thank you.